equal to ax squared plus bx plus c in this one is said to be in the standard form where a, b, and c are constant. A is not equal to 0. For example, we will find the value of A, B, and C. The value of A is equal to 3, B is 0, and C is equal to 0. Example number 2. The value of A is equal to 2, the value of B is equal to 2, and the value of C is equal to 0. Example number 3. The value of A is equal to negative 2, the value of B is equal to 3, and the value of C is equal to negative 6. All of these examples is a quadratic function because they have a degree of
Hello everyone, my name is I am here to discuss about rewriting quadratic function from f of x is equal to ax squared plus bx plus c to f of x is equal to a times x minus h squared plus k, and vice versa. The standard form of a quadratic function is f of x is equal to ax squared plus bx plus c. This function can be written in an equivalent form using the process of completing the square. I will give some example. F of x is equal to 6x squared is equal to x squared plus 6x plus 4. This is an example of quadratic function. Next step, you will factor out a from x squared and x. So you will factor out 1 because your a is 1. The value of x is 1, and when the value of x is 1, you don't need to write 1. Just write x. Next, complete the square by adding and subtracting 6. So it will become x squared plus 6x plus blank plus 4 minus blank. So we will find the c and the value here. And after that, expand the terms and added and subtracted in the previous step. So it will become x squared plus 6x plus 9 plus 4 minus 9. So the missing value is 9. We get 9 because we divided 6, your bx, to 2. And after we divided 6 to 2, we multiply it by itself or square the answer. So we get 9 because 6 divided by 2 is 3. And 3 multiplied by itself is equal to 9. We also put negative 9 here. We just change the sign. And after you factor the and after that, you will factor the trinomial inside the bracket. So the answer would be x plus 3 squared, solve the minus 5. So it will be the final answer. And now we will rewrite the following quadratic function in the form of f of x is equal to a times x minus h squared plus k. We will find a, b, and c. So your a will be 1, and your b is 6, and your c is 4. And we will use the values of h and k to find a times x minus h squared plus k. And the formula to find h is negative b all over 2a. You will just substitute the value of a, b, and c here. So the value of b is 6. So we will put negative 6 all over 2. The value of a is 1. Is equal to negative 6. 2 times minus 1, 2, or let's say negative 3. And using the values of k, we will find the value of k by its formula. And the formula to find k is 4ac minus b squared all over 4a. Equal to 4, the value of a, 1, the value of c, 4, minus the value of b, 6, and squared all over 4, the value of a is 1, is equal to 4 times 1, 4, times 4, minus 6 squared, or 6 times 6 is equal to 36. All over 4 times 1 is equal to 4. 4 times 4, 16, minus 36, all over 4. And now, equal to negative 20 because 16 minus 36 is negative 20, all over 4. Or let's say the answer is negative 5. And now, the value of f of x is equal to ax minus h squared plus k is x plus 3 squared plus minus 5. We change the sign of 3 here. So here negative, we put positive. And copy negative 5. And here they have the same answer.
Hey everyone, I'm Adriel J. Esquibara, and I'm going to discuss properties of the graph of a quadratic function. Properties of the graph of the quadratic function. The graph of the quadratic function is U-shaped curve, or we call that parabola. Given a quadratic function, you should determine the first, highest or lowest point, or the vertex. Next one is direction or opening of the graph, and the last axis of symmetry. The vertex of a parabola is determined from the quadratic function of the graph, f of x, a times x minus h squared plus k, where h and k are real numbers. The direction of opening is indicated by the equation. If a is positive, or a is greater than 0, the parabola opens upward. The vertex is the minimum point or the lowest point of the parabola. If a is negative, or a is less than 0, if a is negative or less than 0, the parabola opens downward. The vertex is the maximum point or the highest point of the parabola. And now, I will give examples to how determine the direction of opening, vertex, axis symmetry, and minimum or maximum of a graph. This one, the opening of this graph is upward. You may see on this graph, the graph is positive, and this vertex is 0, positive 1. This axis of symmetry is 0, y-axis, minimum value, y is equal to 1. This one, the opening of this graph is downward. You may see on this. Her vertex is 0, negative 3, maximum value of negative 3. Oops. I prepared 5 examples to how determine the direction of opening, vertex, axis of symmetry, and minimum or maximum point of each quadratic function. Given f of x, x minus 4 squared plus 6 is given. The parabola opens upward since a is positive. Since h is equal to 4, and k is equal to 6, The vertex of H and K is 4 and 6. This 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. And the graph will be pose. The axis of symmetry passes through the line x is equal to 3. The minimum value is y is equal to 6. The next example is f of x minus 2x squared minus 8x plus 7. The parabola opens downward since a is negative. The vertex is h and k is the vertex is h and k is negative 2 and positive 15. So the graph 1, 2, 15. The axis of symmetry of passes through the line x is negative 2. The minimum value is y is equal to 15. The vertex form is f of x negative 2 times x plus 2 squared plus 15. And it is the another example of the following quadratic function. F of x is equal to x minus 4 squared. Direction opening of the graph is upward. Vertex 4, 0. Axis of symmetry 4. Minimum or maximum value is minimum. Another is f of x is equal to x plus 3 squared minus 1. The opening of the graph is downward. The vertex is negative 3, negative 1. Axis of symmetry, negative 3. The value is maximum. And the last is the f of x equals negative x squared plus 6x plus 6. The direction opening of the graph downward. Vertex is 3, negative 3. Axis of symmetry 3. Minimum and maximum value is maximum. And that's all.
How to graph the quadratic function.
Multiply it.
First, find the coordinates of the vertex, then determine the axis of symmetry. Next, determine the direction of the opening of the graph. Last, make the table of values. If x is negative 3, substitute it by x, then it will become negative 3 plus 5 equals 2. Multiplied by itself equals 8 times 8. Wait na!
Wala na.
3. If x is negative 3, substitute it by x, then it will become negative 3 plus 5 equals 2. Multiplied by itself equals 4 times 2 equals 8 plus 1 equals 9. If the x is negative 4, substitute it by x, then it will become negative 4 plus 5 equals 1. Multiplied by itself times 2 equals 2 plus 1 equals 3. If the x is negative 5, substitute it by x, then it will become negative 5 plus 5 equals 0. Multiply it by 2 equals 0 times 2 equals 0 plus 1 equals 1. If the x is negative 6, substitute it by x, then it will become negative 6 plus 5 equals negative 1. Multiplied by itself equals 1 times 2 equals 2 plus 1 equals 3.
Game.
If the x is negative 7, substitute it by x, then it will become negative 7 plus 5 equals negative 2. Multiplied by itself equals 4 times 2 equals 8 plus 1 equals 9.
Go.
So here, I will graph the x and f of x. So your x will be negative 3 and y is 9.
What you need to what you need to
Hello, my name is Kenneth Pipinto and I'm here to discuss changes in a, h, and k in a quadratic function. The quadratic function is f of x is equals to ax squared plus ax plus c. And I'm going to give an example. X squared plus 2x plus 3. And I will find the A, B, C. A, B, and C. If there is no number within the highest degree, it is automatically become 1. And B become 2. And C become 3. To change A, it is based in the equation. So let's say the given
Your B will be 2.
I gave is 2x squared plus 2x plus 3. The A will
Your A will be.
become 2.
Your A will be na lang.
To know when to change the A, it is always with the highest degree. I prepare the sketch of a graph of some quadratic function of the form f of x equals ax squared for absolute A greater than 1 and absolute A less than 1, compared with the quadratic function of f of x equals ax squared where A equals 1. Also given are graphs of f of x is equal to ax squared where A is less than 0. The vertex is at 0, 0. The line of the symmetry is y-axis, comma, is equal to 0. If A positive, the graph opens upward. And the vertex is minimum point. There is no negative sign, so the graph opens upward. Then if A is negative, the graph opens downward and the vertex is the maximum point. There is negative sign, so the graph opens downward. I have an example. 3x squared. And the vertex of 3x squared is 0, 0. And the direction of opening is upward. Minimum because A is positive. Another one. Negative 4x squared. Negative. And the vertex is 0, 0. The direction of opening is downward because it is a negative. And maximum because it is a negative.
Hi everyone, I'm Generous again and I'm here to discuss about the graph of the f of x equals a times x minus h squared plus k. If the value of a is positive, then the graph is upward. And if the value of a is negative, then the graph is downward. The graph of the function f of x equals a times x minus h squared plus k has the same characteristics as the graph of f of x equals ax squared only. It is the translation of the graph of f of x equals ax squared. Post muna.
Game.
I'll give examples and we will find out the vertex and the opening of the graph. In example number 1, the vertex are 5, 3. So that the opening of the graph is upward. In number 2, the vertex are 3, negative 2. So that the opening of the graph is downward. In example number 3, the vertex are 7, 1. The negative here will become positive. So that the opening of the graph is downward.
I'm Annalyn M. Gonzalez and I'm here again to discuss the derivation of a quadratic function. I will recall that the zero of quadratic function are also the roots of the corresponding quadratic function. Then this is the formula of the derivation of a quadratic function. Then I let y be the quadratic function. Then I'll give an example. I'll give an given negative 3 and negative 4. So I will distribute it to this one. So x minus negative 3, then x minus negative 4. This is the factor of y. So y is equals to x plus 3 and x plus 4. So I will solve it and I will go into
3.
then I'm going to solve it to make it a quadratic equation. So x times x, x squared. 3x times x, 3 times x, the positive 3x. Then x times 4, 4x. Then 3 times 4, 12. Then y is equal to x squared plus 7x plus 12.
Go.
And that x is equal to 0. F of x equal to 0. X squared plus 6x plus 9. Then, factor all the members. X plus 3, then x plus 2. After that, I'll equate it to 0. X plus 3 is equal to 0. Then, other one is x plus 3 is equal to 0. I will solve for x. I will transpose 3 to the other side. So it will become x negative 3, then the other one is x negative 2. So the zeros is negative 3.
3.
And this is the example of factoring.
Three.
Then, in determining the zeros, by completing the square, given x squared plus 4x plus 8. Then, I will go into 4x plus
3.
and I'm going to add negative 8 to both sides. Add negative 8 to both sides. Then I will solve it. X squared plus 4x. So cancel. It will become 0 equals to negative 8. Automatically. The zeros of this equation equals to negative 2. Next, in determining the zeros of quadratic function by using the quadratic formula. Ax squared plus bx
3.
c is equals to 0. This is the quadratic function. Then, x is equals to negative b plus or minus the square root of b squared minus 4ac is equals to 2a is the formula of a quadratic function. Then I'm going to give an example of quadratic equation. X squared minus 3x minus 10 plus 3x minus 10 is equals to 0. Next, and I'm going to find the A, B, and C. A, B, C. The A is 1, then the B is 3. The C is negative 10. I will substitute this equation in the formula. X is equals to negative 3 positive or negative 3 squared, square root of 3 squared minus 4 times 1 times negative 10 all over 2 times 1. So x is equals to negative 3 positive plus or minus positive or negative the square root of 9 minus 4 times 1 negative 4 times negative 10 positive 40 all over 2. Then x is equal to negative 3 positive or negative the square root of 49 all over 2.
3.
Next, x is equal to negative 3 plus plus or negative the square root of 49. 49 is all over 2. X equals to negative 3 positive or negative the square root of the zeros of this equation equals to negative 2. Next, in determining the zeros of quadratic function by using the quadratic formula. Ax squared plus bx
3.
c is equals to 0. This is the quadratic function. Then, x is equals to negative b plus or minus the square root of b squared minus 4ac is equals to 2a is the formula of a quadratic function. Then I'm going to give an example of an example of quadratic equation. X squared minus 3x minus 10 positive 3x minus 10 is equals to 0. Next, and I'm going to find the A, B, and C. A, B, C. The A is 1, then the B is 3. The C is negative 10. I will substitute this equation in the formula. X is equals to negative 3 positive or negative 3 squared, square root of 3 squared minus 4 times 1 times negative 10 all over 2 times 1. So x is equals to negative 3 positive plus or minus positive or negative the square root of 9 minus 4 times 1 negative 4 times negative 10 positive 40 all over 2. Then x is equals to negative 3 positive or negative the square root of 49 all over 2.
3.
Next, x is equal to negative 3 plus plus or negative the square root of 49. 49 is all over 2. X is equals to negative 3 positive or negative the square root of. Then x is equals to negative 3 plus or minus 7 all over 2. Then x sub 1 is equals to negative
3.
negative 3 plus 7 all over 2. Or x sub 2 is equals to negative 3 minus 7 all over 2. So the answer to this is 4 all over 2. Then the other one is negative 10 all over 2. So it will become 2. Then the other one is 5. So the series are is 2 and
3.
last in determining the series of quadratic function from graph. This is the graph x plus 2 squared equal to 0. So it will become 2x. The zero is negative 2 because x plus 2, then the other one is x plus 2 is equal to 0. Then equate it to 0. So x is equals to negative 2. X equals to negative 2. This is the zeros. I'm Annalyn M. Gonzalez and I'm here again to discuss the derivation of a quadratic function. I will recall that the zero of quadratic function are also the roots of the corresponding quadratic function. Then this is the formula of the derivation of a quadratic function. Then I let y be the quadratic function. I'll give an example I'll give an given negative 3 and negative 4. So I will distribute it to this. So x minus negative 3, then x minus negative 4. This is the factor of y. So y is equals to x plus 3 then x plus 4. So I will solve it and I will go into
3.
then I'm going to solve it to make it a quadratic equation. So x times x squared. 3x times x, 3 times x, positive 3x. then x times 4 for x, then 3 times 4, 12. Then y is equal to x squared plus 7x plus 12.
Go.
Hello everyone! My name is Mervina Tinampay. I'm here again to discuss about the nature of the zeros. In the quadratic formula, the algebraic expression b squared minus 4ac is called the discriminant. The discriminant determines the nature and number of roots of a quadratic equation. This is the nature of the zeros. If b squared minus 4ac is equal to 0, zeros are real and equal. If b squared minus 4ac is greater than 0, perfect square and rational distinct. If b squared minus 4ac is less than 0, imaginary and distinct. Here, I will give some example. F of x is equal to x squared plus 3x plus 3. We will find the discriminant here. So we will use the value of d. D is equal to b squared minus 4ac. But before that, we will find first the a, b, and c. So here again is 1, your b is 3, and your c is 3. And now we will solve for the discriminant. You will just distribute. So the value of b is 3. 3 squared minus 4, the value of a is 1, and the value of c is 3. So it will become 3 times 3, 9, minus 4 times 1, 4, times 3 is equal to 9 minus 12, or negative 3. And the discriminant is negative. So, if negative, it is less than 0. So, the nature of zeros is imaginary and distinct.
Every day I'm shuffling.